Thanks everyone for joining this session today. I am Neil Mitra, Enterprise Solutions Architect with AWS. You are here to learn how you can use AWS IoT for building industrial applications. For the agenda, we will start with a quick history of Industrial Revolution. We will talk about the current challenges in the industrial space and the opportunities it creates for industrial IoT. We will discuss about how AWS can help in this space and different use cases related to it. Joining me today is David Bartlett, CTO of Panasonic Aviation, and he will share what his team is working on to change the future. And then we will have a Q&A prior to concluding the webinar. So let's get started. Industrial Revolution refers to the time when the manufacturing industry transitioned from hand production methods to machines. The first revolution happened in the 17th century due to the advancements in steam and power. The second and third industrial revolutions happened in the 19th century with the advancements in electricity and computers. All these revolutions transformed the global economy and helped build today's modern society. The fourth industrial revolution is happening now as we speak. Different countries are referring to this fourth industrial revolution differently. For example, in Europe, it's called Industry 4.0. In Japan, they refer to it as a Society 5.0. And China calls it Made in China 2025 initiative. But the vision behind all these initiatives is similar. The goal is to build smart factories that can help move the country's manufacturing up the value chain. Cloud computing and IoT holds great potential for better quality control, promoting sustainable and green practices, and improve the overall supply chain and efficiency. Transitioning from mass production to mass customization and personalization, moving from CapEx to OpEx, and moving from manual to automotive can help in the smart factory revolution. Core tenets of Industry 4.0 includes cyber physical systems, Internet of Things, cloud computing, and cognitive computing. The goal is to enable new services to optimize machine utilization, reliability, and speed to market. Establish an ecosystem for scattered interoperable devices to scale more easily. Enhance communication between machines and humans in a secure way. And take advantage the scale of cloud to ensure high availability and reduce the downtime. For Industry 4.0 to be successful though, different challenges related to security, downtime, and legacy equipments need to be addressed. If we look into any of the brownfield environments today, the equipment in the field is very difficult to replace, because there are myriad of devices and protocols, and the industrial solutions like SCADA and DCS and PLCs that integrates it seamlessly with enterprise IT systems today needs to be handled as well. Security is quintessential in the industrial plant, and downtime is not an option. And that's where cloud computing, IoT can play a major role to help address the problems and drive innovations beyond what is happening today. Customers can build a new breed of smart applications to collect and use data in real time using machine learning and AI, and to make accurate, actionable predictions what will happen in the future. AWS has been a pioneer in cloud computing, and over the last 1 decade, we have built capabilities across the technology stack from the edge to the cloud that industries can leverage to join the Industry 4.0 revolution. Customers can use edge solutions like Amazon FreeRTOS, AWS Greengrass at the industrial plant for machine-to-machine communications with their PLCs or DCS. Then using connectivity over Ethernet or cellular and different protocols like MQTT and HTTPS, the data can be pushed to the cloud for various use cases, including application consumption, advanced analytics, machine learning, and whatnot. ISA is an international standard for developing an automated interface between enterprise and control systems in a secure way. If we look at the 6 different layers of the ISA architecture, layer 0 are the industrial equipments. Layer 1, the control system like the PLCs and DCS. Layer 2 enables the communication over different protocols like Allen Bradley SIP or OPC UA or Modbus. Layer 3 has the manufacturing execution system or MES that enables running a solution like AWS Greengrass on the industrial gateway to act as a broker to communicate to the cloud. Layer 4 has all the enterprise IT systems like ERP, SAP, CRMs, which can be on-prem or in the layer 5, which is in the cloud. So now we understand the tenets of Industry 4.0 and the vision behind it. Let's discuss some of the use cases to understand how industrial IoT can help here. We will talk about 3 use cases today: predictive maintenance, predictive quality control, and asset condition monitoring. Predictive maintenance helps customers understand the current health of equipments and predict when a machine will fail, prescribe the likely fix, and stage the replacement parts and personnel just in time to avoid impacts to the business. It can improve the performance in the factory by monitoring overall equipment effectiveness. Let's see how the rubber meets the road. In this architecture, sensor data is ingested from the factory machines and vision systems. Monitoring data is ingested from MES or SCADA, routed to a gateway running Greengrass. Greengrass is an IoT solution for the edge. Greengrass provides local MQTT broker, device shadows, certificate authority, local compute and protocol conversions with Lambda and ML inferencing at the edge. It is a software that can run on hardware running various flavors of Linux with a minimum of 128 MB of RAM and 1-core CPU. Greengrass supports a hybrid end-to-end process with local real-time processing and cloud agility for stream processing, analysis, and archival. Data is streamed to the AWS IoT Core in the cloud that can handle billions of transactions from millions of devices. AWS IoT Core offers functionalities of MQTT broker, rules engine, device shadow, CA, and seamlessly integrates with other IoT services like device management to support bulk provisioning, over-the-air updates, and remote monitoring of devices. IoT Core also has a rules engine to selectively route the messages to other services like Pinpoint and Kinesis. Kinesis is a streaming solution that can detect equipment anomalies in real time and trigger notifications with SNS. The data can then be persisted in a data lake using S3 for analytics or for applying machine learning to predict the equipment failures. Using a machine learning service like SageMaker, you can build, train, and deploy ML models for inferencing on the cloud or at the edge. And then visualizing and reporting on various use cases and metrics like equipment time to failure or predictive maintenance can also be done using solutions like AWS QuickSight or partner solutions like Tableau. But what if this architecture could be simplified? As we're continuously iterating based on our customer feedback, we recently launched a service called IoT Analytics. IoT Analytics is a fully managed service that collects, processes, enriches, stores, and analyzes time series data from the IoT devices at scale. The data collection process from machines routing through Greengrass to the AWS IoT Core stays same as in the previous architecture. What changes is how the data is stored, processed, and analyzed in the cloud. IoT Analytics lets you define a channel, select the data you want to collect, configure pipelines, and persist the data into an IoT optimized data store, on top of which you can run analytics using a built-in SQL query engine or apply machine learning using a hosted Jupyter notebooks. And those machine learning models can also be deployed at the edge for inferencing with Greengrass. IoT Analytics also integrates with BI tools like QuickSight or Domo for visualization or dashboarding purpose. One of our customers, an oil and gas company, had the inability to access their IoT data. Other business units within the enterprise owned and controlled the assets in the field, and while many had IoT data, they could not share with each other. By using AWS IoT, the customer is able to pre-process the data coming from the field assets and enrich the data with various other data sources into a time series optimized data store in AWS IoT Analytics. This empowers their in-house data science team to build and train machine learning models on top of data sets derived from the data store. The customer's goals were to validate their hypothesis that IoT data with proper analysis provides meaningful value to the enterprise. Predictive quality control is another use case that helps customers to quickly pinpoint product quality related issues related to factory output rather than equipment performance. For this use case as well, customers have been using Greengrass, IoT Core, and different big data services like Kinesis, Athena in the past. But now it can be simplified using IoT Analytics. So sensor data could be similarly ingested from the PLCs and SCADAs, transitioned to Greengrass to the IoT Core. What is different here is the images from the vision system can be sent directly to S3, and time series data can be pushed to IoT Analytics data store. This is needed as S3 can act as the data lake for static assets like images and videos, and machine learning models for image analysis can be built and trained on this data, and then can be deployed back to the edge for real-time inferencing. Valmet is a customer who delivers technology and automation with multiple dependent processes running in parallel. Valmet is building a new digital twin capability to allow paper mill operators view equipment and process data during production runs. AWS IoT Analytics is at the core of their solution and helps Valmet to enable their customers to produce paper with low cost and optimum quality. The third use case is related to asset condition monitoring. This helps customers to monitor and scale industrial equipments and understand the asset condition for various parameters like temperature, vibration, error codes, etc. Similar to the last two architectures, this can also be implemented using Greengrass, IoT, and different big data services. But now it can be simplified further with IoT Analytics as well. As you can see, the complexity of learning and managing different other services can be reduced, achieving the same goal. Our customer, a global mining company, they were looking to measure rough roads on mines, as potholes can cause damage to the mining equipments, which are extremely expensive. They used AWS IoT to place gateways and vibration sensors on trucks. The customer now can collect data from various equipment, such as the excavators, which allows them to identify potholes and other problems on mining routes. Now, they can continuously monitor equipment status, health, and performance to detect issues in real time. Let's try to map the Industry 4.0 tenets to the AWS services. For interoperability, you can use local Lambda with Greengrass. For virtualization, you can use IoT shadows that can work either at the edge or the cloud. For decentralization, AWS IoT is available in 11 regions around the globe. Real-time capability can be achieved with Greengrass again. Service orientation can be achieved with Lambda functions, orchestrated with step functions invoked by AWS IoT or API gateway. Modularity can be supported by Greengrass. Security is our top priority. All communication needs to happen over TLS. In addition, we are launching AWS IoT Device Defender service, which is in beta now, that secures your fleet of industrial endpoints. Analytics, you can achieve through AWS IoT Analytics service, as you just saw in the previous architecture. And lifecycle device management can be done with AWS IoT Device Management, which makes it easy for you to securely onboard, organize, monitor, and remotely manage devices at any scale. To wrap up, the customers choose AWS for various reasons. Firstly, because of our innovation is in our DNA. We help customers focus on transforming their business and let us do the heavy lifting. Our breadth and depth of services. Last year alone, we released more than 1,400 new features and services for our customers. We are the pioneer in cloud computing. We have more than a decade of experience, and we believe there is no compression algorithm for experience. We have 18 regions now globally and 4 more on the way. And Amazon had been using machine learning and AI for more than last 20 years now in our industrial plants as well, even when it was not considered such a cool technology. And finally, we are obsessed about our customers and we partner to help them. We have added more than 10,000 new partners to the Amazon Partner Network last year alone. Thanks for being patient with me, and now I will request David Barrett to share his story of Panasonic Aviation. Thank you.
Well, thank you. My name is Dave Bartlett, CTO in Panasonic Aerospace. And I am delighted to be speaking with you today, and certainly delighted to be partnering with Amazon Web Services to deliver a wide range of insights to our customers in the aviation space. So to introduce our business, Panasonic is the world's leading in-flight entertainment and connectivity solution provider. We work with airlines and companies in other markets such as maritime to provide solutions and services that meet the needs of their passengers and employees and help build their businesses and brands. So, if you look at just the aviation sector alone, Panasonic is currently working with over 300 airlines across the globe. And there's over 9,000 aircraft flying today with the Panasonic in-flight entertainment systems, and over 2,000 aircraft connected to our global network of satellites that's enabling a huge range of passenger services and airline solutions. And we expect that number to grow to 10,000 aircraft by 2025. So a very fast-growing industry here. And this includes Wi-Fi, mobile phone services, global live television, and other areas. We recently launched our 3rd generation network, combining the benefits of extremely high throughput satellites across all high air traffic regions, and also new modem technology to be able to offer as much as 20 times greater bandwidth in the skies. So huge advances in this area. Now, these latest evolutions in in-flight entertainment, and connectivity are enabling us to harness and analyze the data from those systems, providing new insights which open up a wealth of enhancements to the passenger experience, from hyper-personalization through loyalty to more regularly served content, more in-flight retail opportunities, much more. So in a nutshell, my mission is really to help craft the next generation of in-flight experience. So if you just look at it from a global footprint point of view, you see that our footprint is around the globe, very much a global operation. And more than just providing that service, we are also providing the maintenance of those services and the loading of content to each of those airlines. So we've got a huge inventory at our line stations, over 195 million. We do over 500,000 service events each year. We have well over 1,000 technical services professionals, and you know, we've been doing this for over 36 years. So it's one of the oldest maintenance for these type of systems in the aviation industry. So very much a big part of our business that is continuing to grow rapidly. Recently, we announced something that we call Next Cloud. It's Panasonic Avionics' new global ecosystem, and it's powered by AWS to manage the synchronization and utilization of these cabin service data sources, both on and off the aircraft and within the airline's business operations. So what are these data sets? Well, they include a variety of sources that are in service today and growing. So the passenger usage data of these systems, the metadata associated with the media and advertising, content such as daily news, operational performance data, and the synchronization of our business rules for dynamic applications that include things like retail or least cost data routing and more. So it's really the foundation of a set of core application services that we're enabling, again, for this next generation of in-flight experience. And right now, our big focus is on a new level of theater we call Next Theater, hyper-personalization called Next Loyalty, and also Next Marketplace. So these new value-added solutions are really being added to help airlines realize the new outcomes that they wish to have to achieve the differentiation in the marketplace they're looking for. So this is you know, my one obligatory architecture chart here. So we're starting with our next hardware and software platform. This is our head-end servers that fly in the plane, the connectivity connection, the software that runs the head-end servers on the plane and distributes content to each of the devices in the seat backs, to the cabin monitoring system that the flight attendants use, etc. And we've made some recent advances here. We can deliver up to now 4K quality on these screens. Next online is the connectivity services. This is the antenna that you see in the bubble on top of planes, and our satellite network that's delivering the new level of connectivity that we as flying public are coming to expect and demand more and more. And this is all served now by this foundation that we call Next Cloud. Again, it's built on AWS. In the aviation industry, it's really the first global data analytics centric IoT infrastructure. So we're really excited about it. We're really excited about the new outcomes it's going to help to drive in spaces like you see in loyalty, in marketplace, in theater. So it's we're looking to make a seamless experience in the travel thread as people board planes that is continuous with what they've done to pre-select or pre-order content or to continue content from their last flight to new outcomes in marketplace. That's a much more tailored retail platform of how you purchase goods, services, foods on the plane, and then taking theater to a whole new level. We believe we've got the type of hardware now supported by this platform that offer the latest in cinematic experience, entertainment, gaming, etc. So the challenge in doing all this, of course, as was described in the last speaker, was how do we do this effectively? Because it is an IoT and analytics play. Well, today we're doing this very much as kind of a sneaker network, one that takes a lot of time to collect the data after each flight, put it in the warehouse, do the analysis, and continually try to improve services. That clearly is not going to scale to the new real-time outcomes that we're looking to drive. So what we're working with Amazon to do is, by using the AWS cloud infrastructure and IoT platform that they've built, be able to pull in real time the data from the onboard servers, the crew interface, the seatback and devices, the maintenance of our equipment, etc., and pull it into the cloud. This is going to make for a much quicker real-time analysis. It's going to enable predictive capabilities that we haven't had in the past, and really be a platform for these new outcomes that I'm talking about. So the value is, to me, is when you put analytics, data science together with IoT, that's where the magic is going to happen. So through the use of AWS IoT and IoT Analytics, we're able to dramatically lower the time it takes to get this deep insight that's needed to increase our operational efficiency, and in terms of maintenance, reducing our spare inventory costs, because we can do things much more proactively than we have with the past systems. Now, this will enable us to schedule field engineers and parts as the planes land to help the turnaround time of those aircraft and reduce those inventory costs. This is a huge, huge benefit moving forward. And because aviation hasn't been connected with these cloud capabilities in the past, it's largely not been done, which is why it contributes to a lot of the delays that you see on the ground or system outages. So this is really going to help fast forward us to future capabilities, and in addition support these new outcomes, as I mentioned earlier, in terms of marketplace, theater, loyalty. And these are just examples of some of the outcomes we're going to be driving much more as well. So let's go a little bit deep dive into this analytics solution. Well, it really starts with, for me, as we set up the cloud capability, which we've done, it's up, it's running, we've already getting great value, but it starts also with the green grass capability that Amazon is providing. Now, what is that? In aviation terms, it's the ability to process events on the plane locally without having to have a constant connectivity to the cloud. This is very much a cloud edge architecture. So in this case, the plane is the edge, the cloud is on the ground, and even though we're working tirelessly to improve connectivity to the plane, a good architecture should not have to require constant connectivity. Why? Because even with great connectivity, you've got latency, and there's a huge cost in having to send everything to the cloud and back. So there's quite a number of events we can handle locally from the server on the plane using this green grass capability that Amazon IoT platform provides. Of course, we also have the benefit of when we can connect to the IoT service in the cloud, and we'll use a rules engine to decide what to do with what's coming in, as the previous speaker mentioned, whether we're pushing it to IoT Analytics in the cloud and to our data store or data lake, and doing visualization with Amazon QuickSight or some of our other BI tools as well, but also the ability to forward to the Dynamo database as well, which is where we're storing all of our events. And this is just an example of a QuickSight dashboard that we're really pulling in a number of events. So we've already done some of this work to begin to look at events, and these are basically fault events that are coming in, and being able to segment them by event types. So example would be fault events coming from the audio systems, or from the screen systems, or from the head and server itself. And of course, this is just the beginning, but a powerful visualization tool to help us quickly segment, visualize, and respond to events. But as we move forward with the analytics, this is just an example from some work we've done in Marketplace, where we're extending our ecosystem to work with a supply chain of goods and food to the airline, and understanding the marketplace much the way we do in ground retail systems. This is what the Amazon IoT platform is going to enable us to do in a much more responsive manner. And understanding things like conversion rate of a shopping cart, or cart abandonment, or returns, or bounce rate. This is how we improve the returns for the airlines in terms of ancillary revenue, but also improve the shopping experience for customers. Constantly looking at what's the best set of goods to have on board, how to better deliver the food that people want, how to reduce wastage, delivering the wrong type of food or goods to a plane that have to be discarded afterwards. So very exciting journey that we're on with Amazon. We're excited, as I said, to be a partner. I have to say how impressed I am how quickly we've been able to put this platform in place with Amazon. The IoT framework, I believe, is unique in the industry in its ability to create an IoT platform in the cloud and to scale at levels that other platform providers have not been able to do. As I showed you in my earlier charts, we have a big network to support. We need to do something that doesn't just work for the first few planes, but is going to scale to 10,000 and more planes as we move forward. AWS IoT Framework is the one that's going to get us there. So with that, I'll say thank you, and I guess we move to Q&A.